15.5 Series and Parallel Inductors. In this session, we're going to talk about how to connect inductors. Similar to resistors and capacitors, there are two unique ways to connect inductors. They are series and parallel. Let's see how to connect inductors in series. Here we have n inductors connected in series. They are inductor 1 called L1, the second inductor L2, inductor L3, connect to the last one, the Ln, the nth inductor. If all these inductors are connected in series, the total inductance, let's call it Lt, equals to the sum of all these individual inductance. That is L1 plus L2 plus L3 plus all the way to Ln. We can conclude that when inductors connected in series, the total inductance is additive. Let's work on this example. There are 4 inductors connected in series in this circuit. The first one has a value of 3 Henry, and then 1 Henry, 5 Henry, and the last inductor has a value of 10 Henry. What is the total inductance of this system? Put the circuit to the side, and then we can apply that formula. Since this circuit has only 4 inductors, we just need to take the 4 terms of that formula. So Lt equals to L1 plus L2 plus L3 plus L4. Plug in numbers. 3 Henry plus 1 Henry plus 5 Henry plus 10 Henry. After adding them up, it is 19 Henry. This is how we connect inductors in parallel. As you can see, the way to connect inductors in parallel is same as connecting resistors in parallel. This kind of connection is not new to us. It is easy peasy. In this figure, this schematic, the circuit looks like a ladder. The total inductance Lt can be calculated this way. And this formula is not new. It's similar to finding the total resistance of a n parallel resistor circuit. That formula, the reciprocal formula. So 1 over Lt equals to take reciprocal of every term, every inductor, and then add them up. Now let's work on this example to find the total inductance Lt of these 3 parallel inductor circuit. L1 equals to 2 millihenry. Second inductor L2 equals to 3 millihenry. And L3, the third inductor, is 6 millihenry. To find the total inductance, use the general formula, but only keep 3 terms, since there are only 3 inductors here. That formula is 1 over Lt equals to 1 over L1 plus 1 over L2 plus 1 over L3. Next step, plug in the numbers. L1 is 2 millihenry. 1 over L1 is 1 divided by 2 millihenry plus 1 over 3 millihenry plus 1 over 6 millihenry. For the next steps, there are at least 2 ways to solve the problem. One way is to rationalize the denominator, which means by finding the common denominator among all 3 denominators. Between 2, 3, and 6, the common denominator is 6. So we change every term's denominator to 6. For the first term, the denominator 2 becomes 6. We need to multiply a 3 to the denominator. So we multiply a 3 to the numerator as well. First term is 3 over 6 millihenry. For the second term, the denominator 3 becomes 6. To reach to that 6 millihenry, we multiply 2 to the denominator. So we need to multiply 2 to the numerator as well. So the second term is 2 over 6 millihenry. For the third term, the denominator is 6 millihenry already, so no need to multiply anything to the numerator. And now we combine these three terms. The denominator is 6 millihenry. For the numerator, we just add them up. 3 plus the 2 plus the 1 equals to 6. So 6 over 6 millihenry, that is 1 millihenry. At step 1D, we get 1 over LT equals to 1 over 1 millihenry. So if we can flip both sides of the equation, we bring the denominator to the numerator to denominator, which means we take a reciprocal for both sides. LT equals to 1 millihenry. Total inductance of this system is 1 millihenry. This is the first method. The second method is my third method for solving this kind of question. To me, it's easier, but for anyone who just start learning this, it might be a little bit confusing at the beginning, especially the unit part. How about let me show it to you, and you decide which method to use. We go back to step 1A, continue from there and use the second method. So copy down that 1 over LT. The right-hand side of the equation has three terms. 1 over 2 millihenry plus 1 over 3 millihenry plus 1 over 6 millihenry. Don't worry about the unit for now. Just put these numbers into a calculator. In the calculator, I enter 1 over 2 plus 1 over 3 plus 1 over 6. That equals to 1. The unit here caused some confusion. Let's look at the step 1A again. On the right-hand side of the equation, every term has millihenry. The unit of the final answer must be millihenry as well. It just cannot be either prefix or unit. Regardless of all these terms, we just put the millihenry here. However, this is 1 over millihenry or millihenry to the negative 1. The reason is the value here is the reciprocal of the total inductance, LT. Take the reciprocal of the unit here just to match with the expression, the 1 over LT. And after flipping both sides of the equation, the left-hand side is LT, the total inductance. On the right-hand side of the equation, we flip both the number and the unit. The result becomes 1 millihenry over 1, which is 1 millihenry. To me, I prefer the second method. It's easier. During the calculation, we don't need to worry too much about the unit. Once we calculate the final answer and put the unit at the end. One thing over here is make sure we need to align all the prefixes, which means all terms have same prefix. For example, at step 1A, for this question, all terms, all numbers units have the same prefix, which is milli. For a question, the numbers have different prefix such as milli, micro, nanos. We need to determine a prefix and change all terms prefixes to this prefix, such as change all the milli and the nano to micro, or micro and nano to milli, or micro milli to nano. Just decide one prefix and change all other prefixes to this determined prefix, and then apply the same procedure, the same steps to find the final answer.